We need to simplify square root of x squared minus 25 over x by using this substitution. X equals 5 secant theta. And theta is between 0 and pi over 2. It's in the first quadrant, so all the trig functions are positive. This could be done in two ways. The first way is to simply use algebra. So rewrite the expression square root of x squared minus 25 divided by x using the substitution. So the numerator is square root of x squared becomes, if x is 5 secant theta, x squared is 25 secant square theta. So that's x squared, and I need minus 25 in the square root divided by x. X is 5 secant theta. So let's copy that. And it's a matter of simplifying, rewriting, and simplifying. So in the numerator under the square root, I can factor out a 25. Then I have secant square theta minus 1 over 5 secant theta. So notice secant square theta minus 1 is tan square theta. That comes from the Pythagorean identity 1 plus tan square is secant square. So secant square minus 1 happens to be tan square theta. So I can replace everything inside the parentheses by tan square theta over 5 secant theta. So the numerator is now square root of 25 is 5 and square root of tan square theta. Well, this is where I'm going to use this idea that theta is in the first quadrant. So tan theta is positive. So square root of tan square theta is simply tan theta. I don't need the absolute value of tan theta over 5 secant theta. So we can get rid of the 5's, cancel out the common factor, and let's rewrite everything in terms of sine and cosine and see what we get. So tan theta is sine theta over cos theta. So sine theta over cos theta. And secant theta is 1 over cos theta. So notice I have a complex fraction, but the numerator and denominator, they both have cosine theta as a denominator of each of those parts. So we can get rid of the cosine theta. Or if you want, you could write this as sine theta over cos theta times cos theta over 1. You flip this over and multiply. So either way, it happens to be simply sine theta. So let's go ahead and box our answer. And here is a comment. So notice, you have a complicated expression that looks like this, square root of x squared minus 25 over x. Now, with a nice substitution, we turn this complicated expression into something as simple as sine theta. And sometimes it's required. We may have to work with this expression, but it would be extremely difficult to work with something like this, but we can turn it into sine theta. Now this is one way to rewrite. The other way to do is to draw a right triangle. And using this idea that x is 5 secant theta, I'm going to evaluate this expression. How? So let's go ahead and draw a right triangle. Call one of the acute angles as theta. And you're given x is equal to 5 secant theta. If you divide both sides by 5, you get x over 5 equals secant theta. Now we usually work with sine, cos, tan. So secant is nothing but the reciprocal of cos. So if you know secant theta, then you know cos theta because it's a reciprocal. So it's going to be 5 over x. So you want to get an expression for something that in either sine, cos, or tan. So cos is 5 over x, and cos is adjacent over hypotenuse. So when in your right triangle, you want to write the adjacent side of theta as 5 and the hypotenuse as x, because that's cos theta. And then you can find out the third side. So using Pythagorean theorem. So how do you find the third side? Well, you square the hypotenuse and square the other leg and subtract. So it's going to be square root of x square minus 25. And notice this expression, square root of x square minus 25 over x, is nothing but opposite over hypotenuse. And opposite over hypotenuse is sine theta. So we could have looked at this picture and said, oh, this expression is simply sine theta, which is what we got using the algebra and the trig identities.